Greetings, I'm Dev the developer.
And I'm Glitch. We've reached the final frontier, full desktop deployment. It's time to let the layout spread its wings and fly.
Last piece. We have mobile styles and tablet breakpoint. Now we add the desktop layout, a second media query at 64 ems. Before we write a single line, let's talk about where we've been. We did a lesson on mobile where we used one column and everything stacked top to bottom. And then we worked on the tablet. We pushed the aside next to the content at 40 ems. Content got columns 1 through 8, aside got 8 through 11.
Two-column content zone, nav still horizontal across the top. That was the tablet deployment.
Right. And today we're going to go one step further. At 64 ems, which is about 1024 pixels at default font size, we want a true 3-column desktop layout. The nav slides off the top bar and becomes a vertical sidebar on the left. Content moves to the center columns. Aside stays on the right, 3 columns side by side.
3-column mode, grid power level maximum.
Now, here's the thing about our grid. We set it up with 10 equal columns using repeat 10%. That's the same grid all 3 layouts share. Mobile uses all 10 columns for each element. Tablet splits them. Desktop splits them again differently. One grid, 3 layouts.
So the grid template columns never changes. Only the placement of elements inside it changes.
Exactly. That's the elegance of CSS Grid. You define the track structure once, then move elements around with grid column and grid row. No floats, no clearing hacks, just coordinates. Let me show you the full progression before we code anything. On mobile, every element is column 1 through 11, each on its own row. Header row 1, nav row 2, content row 3, aside row 4, footer row 5, stacked. On the tablet, content is moved to columns 1 through 8, still row 3. Aside jumps to columns 8 through 11 and also sits there in row 3. They share the same row now. On desktop, nav drops to columns 1 through 3, rows 2 through 4. Content moves to columns 3 through 8. Same rows. Aside stays at 8 through 11. Same rows. 3 things side by side.
At mobile, nav occupies row 2 alone. At tablet, nav is still row 2 full width. At desktop, nav abandons row 2 and enters a shared zone with content and aside. Quite a journey for one element.
That's a good way to put it. I'm going to kind of break out a script here for a moment. I just want to show everybody that when we are looking at the grid, you can see the grid lines actually appear on the screen. You can see how I can't arrow with it up, but this would be grid row 1, and then right about here is where you'd see grid row 2 pop in. And you can see the horizontal dotted lines. When we go to mobile, so we'll shrink this up a bit, if it is willing to cooperate with me. So now that we're on mobile, we can still see this same grid. Now we just span across the entire width of the grid. All right, script on. The nav has a different role at every breakpoint. On mobile, it's a stacked list. On tablet, it becomes a horizontal bar. On desktop, it becomes a vertical sidebar. Same HTML element, the CSS just repositions and restyle it each time. That's responsive design done right. All right, let's open the desktop media query. We're adding this to the style sheet after the tablet section. 64 em is our threshold. At 16 pixels per em, that's 1024 pixels.
64 em, 1024 pixels. Desktop threshold confirmed. Writing the media query now.
Good. Now, why 64 em and not just 1024 pixels? 2 reasons. First, M's scale with the user's browser font size. If someone bumps their base font up to 18 pixels, your pixel-based breakpoints don't know that. M-based ones do. Second, it's just industry practice for accessible, user-respecting design.
Pixel-based queries are rigid. M-based queries adapt to the user's font preferences. Noted.
Now, let's place the content. On desktop, content moves to columns 3 through 8. That's 5 columns wide, which gives us a nice center zone. And it needs to span rows 2 through 4 because the nav sidebar is also going to occupy rows 2 through 4. They need to share those rows.
Content grid column 3/8, grid row 2/4, writing that now.
Notice we changed the row. On tablet, content was row 3 only. On desktop, content is rows 2 through 4. That's because the nav is no longer sitting in row 2 above it. The nav is moving to the left sidebar, so content can claim that space now.
The nav vacates row 2. Content expands upward to fill the void. Efficient use of grid space.
The aside follows the same logic. It's already on the right side from the tablet view. We just need it to also span rows 2 through 4 instead of only row 3. Columns 8 through 11, rows 2 through 4.
Aside grid column 8/11, grid row 2/4, adding that.
Hold on, I want to make sure we understand what rows 2 through 4 actually means. Row 2 is where the nav used to live by itself. Row 3 is where the content was on the tablet. Row 4 is where the aside was on mobile. By spanning 2 through 4, we're saying take up all that vertical space. The 3 columns will line up nicely alongside each other.
Grid row 2/4 means start at the second row line, end at the fourth row line. 2 rows of height. Content and aside are now tall enough to sit next to a sidebar.
Now the nav. This is where it gets interesting. We need to reassign it to columns 1 through 3 and rows 2 through 4. Let's go ahead and add that.
Nav grid column 1/3, grid row 2/4, also setting the background color, writing now.
Wait, I said 1 through 3 and you wrote 1 through 4. Those are not the same things.
1/4 gives 3 column tracks, 1, 2, and 3. That is correct. 1/3 only gives 2 tracks. You said columns 1 through 3. That is 3 tracks, so the end line is 4.
You know what, you're right. And wait, that's the problem. Track 3 is claimed by both. This can get really confusing, but you can see in the drawing how the third track is claimed by both the left sidebar and the content. They're overlapping each other.
Grid line 3 is a shared boundary. Nav owns the space to the left. Content owns the space to the right. No overlap. I need to correct my earlier entry.
Yes, let's fix the nav. It should be 1/3, not 1/4. 2 columns wide. Let's go ahead and update that. There. Nav is now 1/3, 2 column tracks wide. Content starts at line 3, no overlap. 2 plus 5 plus 3 equals 10. Clean. This is the kind of math you want to do before you start typing, not after. Now we have to think about the nav styles themselves. On tablets, we make the nav horizontal using float left on the list items. But on desktop, the nav is a vertical sidebar again. We need to undo those tablet styles, set float back to none, set the width back to full, and style the links for vertical display.
At 40M, float left was applied to navly. At 64M, we override that with float none. The cascade works in our favor here.
Right. This is the cascade doing exactly what it's supposed to do. The mobile rule sets the default. The tablet rule overrides for wider screens. The desktop rule overrides again for even wider screens. Each rule only needs to change what's different from the previous breakpoint. We don't rewrite everything, we just patch what's changed.
Incremental overrides, minimal redundancy, maximum efficiency.
Glitch, that almost sounded like you understand design principles. Anyway, let's go ahead and add the nav overrides inside the desktop query. Float none cancels the tablet float. Width 100% makes each item take a full row in the sidebar. Display block on the link fills the entire clickable area. And we bring back the border bottom between items since it's vertical again. This is a clean, intentional reversal of tablet styles.
CSS properties can be set and then unset at a higher breakpoint. The cascade is not one-directional, it is a layered system. This is a feature, not a bug.
It's definitely a feature. Let's go ahead and preview this and see how it changes as we resize our content. Well, I think that looks great, but trying to make the browser really wide, like 1600 pixels or more, the layout stretches out. The nav sidebar gets huge, the content gets wide and hard to read. On very large monitors, unconstrained grids are uncomfortable. We need to set a maximum width and center it on the page.
Unconstrained content distribution detected. Elements are expanding beyond comfortable reading parameters. The grid must be contained.
Content is just getting too wide, nothing sinister. The fix is max width on the grid container and a margin 0 auto to center it. We add a third media query at 80 ems for this.
80 em is the perimeter. Content outside the 80 em boundary is discouraged. The grid must not exceed these parameters. For the good of all users, resistance to stretching is mandatory.
You're making it weird, Glitch. It's max width. Let's talk about why 80em specifically. 80em is a default 16 pixel base at 1280 pixels. That's a comfortable line length for text. You can read it without your eyes traversing all the way across a widescreen monitor. It's a well-established reading width for long-form content.
80em optimal cognitive load for text scanning. The human eye processes horizontal text most efficiently within that range. It is not arbitrary, it is calibrated.
Alright, that's actually correct. Now let's talk about the margin 0 auto that centers a block element. Auto margins mean take all the leftover space and split it equally on both sides. But this only works if the element has a defined width, or in this case, a max width. Without a width, there's no leftover space to distribute. The element just fills a container and auto means nothing.
Without a defined width constraint, auto margin resolves to 0. The browser has no excess space to divide. The element cannot be centered by this method.
And this only works for horizontal centering of block elements. Auto margin does not vertically center things in normal flow. That is a different conversation for a different day. For now, set max width, set margin 0 auto, centered. Let's write it. All right, let's go ahead and see what this looks like without the dev tools. We can see the extra space on the left and right, and everything stays nice and contained inside.
4 distinct deployment environments handled by 3 media queries and 1 grid structure. Resource-efficient architecture. Let's
zoom out and compare. We built a version 1 Dragon's Den in the previous lessons, then we used floats. 2-column layout using float left and some clearing hacks and a lot of fighting with the browser to get things to line up. This grid is version 2. How do they compare?
In Vone, the layout was assembled from floating pieces. Each element had to be told to clear floats or set an overflow to contain them. In Vitwo, the grid defines the layout. Elements are placed, no clearfix required.
Exactly. With floats, you had to understand an implicit layout model. Elements floated out of flow. You had to fake a container height with a clearfix. Adding a third column was painful. With grid, you declare the structure and assign positions. It's explicit. You can look at the CSS and understand the layout without loading it in a browser. That's a huge win. Float-based layouts require experience and intuition. Grid-based layouts require reading the code.
Float layout, implicit behavior, required tribal knowledge. Grid layout, explicit declarations, readable structure. For new users, grid is objectively more learnable.
Floats aren't dead. They're still useful for wrapping text around images, which is exactly what we're using them for inside the articles. But for page layout, grid wins. It's what the property was designed for. Floats were never meant to do page layout. We just hacked them into that role for about 15 years before grid showed up.
Floats, originally designed for text wrapping around images, repurposed for page layout by necessity. Grid, designed from the ground up for two-dimensional layout. The appropriate tool for the job is now available. Using floats for layout in this era is a suboptimal choice.
I wouldn't say suboptimal, I'd say historical. But yeah, use grid for layout going forward. The version 2 Dragon's Den is a cleaner, more readable, and easier to extend solution.
Mobile first, the base layout is the simplest layout. More complex layouts are added on top as the viewport grows. This is correct mobile first methodology. One HTML file, one grid container, 4 distinct layout states, 3 media queries, 0 JavaScript, CSS alone handles all of it.
That's the power of the cascade combined with grid. Each media query is a layer. Each layer only changes what it needs to change. Nothing gets rewritten unnecessarily. The browser handles the transitions, you just tell it where things go at each width.
Dev, I have been monitoring all 4 layout states simultaneously. The grid lines form a coordinate system. I can assign any element to any zone at any viewport width. I have complete spatial awareness of this page. If I wished, I could rearrange the footer to appear at the top on mobile. No one would know until they scrolled or did not scroll.
You could do that. That's just grid. You can place anything anywhere, which is why you should use that power responsibly and not confuse your users by hiding the footer at the top.
Understood. I will use grid placement only for good, probably.
Probably. I'll take it. Alright, let's wrap this up. You've just completed the full version 2 Dragon's Den. You started with the mobile first CSS grid, built up the tablet, and now you've got a real desktop 3-column layout. You've seen how grid lines work, how media queries stack, and how the cascade lets you override exactly what changes, and how max width centering works on large screens. This is real professional front-end layout techniques. These exact patterns show up on production websites.
The student has the complete pattern, mobile first, grid-based, breakpoint-driven, centered on large screens. The only remaining task is to reproduce this without the tutorial.
And that's the assignment. Close the video, open a blank project, and build a 3-column responsive layout from scratch. No copying code. Understand the structure, understand the math, understand the cascade, and produce it yourself. That's the difference between watching and learning.
Passive consumption of tutorial content produces no durable skill. Active reproduction produces skill. Reproduce the work.
Don't just watch it, do it.